Okay, welcome to Unit 5, Day 5. We'll be looking at quite a few graphs and labeling them based on various points that we see in these graphs. So, to begin with, we're asked to, well, it's usually best to start with the x-intercepts if you can, because a lot of the information that we'll be looking at depends on knowing the x-intercepts. So just by looking at this graph, we can see that the x-intercepts are -1 and 5. So we'll fill that into our chart right there. Halfway between the x-intercepts is what's known as our axis of symmetry. It's an imaginary line that divides our parabola in half, and either side reflects on the axis of symmetry to the other side. So -1 is 3 units away from the axis of symmetry, which means that 5, the other x-intercept, will be on another 3 units to the right of the axis in symmetry. It's reflected, as we say. The y-intercept is the point where the graph crosses the y-axis. You can see that that is 3, or sorry, -3. So at the point -3, the graph crosses the y-axis. We say that's the y-intercept. So we'll put that into our chart. Our vertex, as we can see in the graph, is at the coordinate 2, -5. So we can just write that in. And the direction of opening of the parabola is up. So we can put that in as well. So these are the key points or key coordinates of a parabola. In this example, we're shown the equation, and then we're asked to come up with different points just based on the equation. Now, one of the easiest things to determine about this parabola when it's in when it's in standard form is just what the y-intercept will be. The 8, in this case, the value of c in our ax squared plus bx plus c format, this 8 will indicate what the y-intercept is. So we know that the graph or the parabola is going to cross the y-axis at the point 8. So we'll just put the little dot there. We'll mark a coordinate point there. Now, factoring it, or putting it into factored form, tells us that our x-intercepts are going to be -4 and -2. So we took this equation that was in standard form, x squared plus 6x plus 8, and we factored it. We found two values that would add up to 6 but multiplied together to be 8, and those just happen to be 4 and 2. So we can say x plus 4 times x plus 2 is our factored form. What this tells us is that our x-intercepts are -4 and -2. So we'll put those x-intercepts right there. Now, to calculate the axis of symmetry, that is the midway point between the two x-intercepts, we simply add the two x-intercepts together and divide by 2, which gives us a value of -3. So negative 3, or x equals negative 3, is our axis of symmetry. We'll just draw a little line there. Once we have our axis of symmetry, we can take that x value of negative 3 and substitute it back into the equation to figure out what the y value of the vertex is. So we'll take that negative 3, plug it back into the equation, and we're given or end up with a value of negative 1. So our vertex will be negative 3, negative 1. And we can roughly sketch in our parabola now that we have enough points. So our parabola would end up looking like this. Now in this example, we're given an equation y equals negative x squared plus 4x minus 3. We can see right away that the value of c is negative 3, which tells us that our y-intercept is going to be negative 3. So we can just plot that in. Now the next thing we want to do is we want to put this into factored form, but a negative value in front of the x squared is very difficult to factor. So before we factor it, we're going to try and get rid of that negative x squared. The way we do that is we just put a negative in front and then factor the rest accordingly. So what we end up with is x minus 3 and x minus 1, which gives us x-intercepts of 1 and 3. Once we have our x-intercepts, we can add them together and divide them by 2 to give us our axis of symmetry. And this ends up being 2. And once we have a value, an x value for our axis of symmetry, we can simply plug that back in, that 2 value, into our original equation to give us the vertex. When we do that, we end up with a value of 1 for y. So we know that our vertex is 2, 1. And now connecting the various points, we can roughly sketch in our parabola. In this example, we're given the standard form of 2x squared minus 4x minus 6. This can be further simplified with the greatest common factor of 2. But before that, let's take note of the fact that our c value is negative 6. So negative 6 becomes our y-intercept. Now, let's simplify our equation by taking the greatest common factor of 2. Simplifying it would become 2x squared minus 2x minus 3, which can be put into factored form. 2x minus 3, x plus 1, giving us intercepts of negative 1 and 3. To find the axis of symmetry, we add negative 1 and 3 together, giving us a result of 1, so our axis of symmetry is 1. Now that we have an x value for the axis of symmetry, we simply plug that 1 in to the original equation to give us the y value of the vertex. And we do that and end up with a result of -8. So our vertex is 1, -8. Connecting the points, we can sketch in our parabola. It looks something like this.